Hi, I'm Sam Lang, and today I'm going to be talking about the structure of the nucleus. So, the nucleus, something pretty basic that we all know about. A little background into how the nucleus came about. The first person who proposed the idea of an atom and the nucleus, his name is Democritus. He was a Greek philosopher, but studies also show that in other parts of the world, people were hypothesizing that there is something that is, a very small atomic particle, such as in India and China. But he came up with the word atom, or atomus, which means uncuttable in Greek. And then hundreds and hundreds of years later, scientists began to kind of investigate as technology progressed into what exactly is the atom. And kind of the scientist who put forth the most effort in this is John Dalton. And he worked with other contemporaries to kind of come up with models and theories of what exactly a nucleus is and how it is composed to make up an atom. And of course, he gets help from his friend Amedeo Avogadro, and he's the one who actually comes up with what a fixed number is, and that's how we get Avogadro's number of moles and what makes up a total number of atoms, and something that we can measure because they are extremely small. And then some more background into atoms. They move by what's known as Brownian motion, which is the motion of thermal energies or caused by thermal energies, and it's that atoms basically colliding and running into each other and then bouncing and bouncing off. And so into kind of the structure of what makes up the nucleus, right? So here's just some crude drawings of an atom. This kind of represents the atom structure, and as you can see, they're very small. An atom is 10 to the negative 10th meters in diameter. And then when we're measuring the length of the nucleus itself, which is made up of the proton and the neutron, we get a 10 to the negative 15 meters, so very, very small. And like I said, the nucleus is made up of a proton and a neutron. The proton here obviously has a positive charge, positive for proton, and it has a charge of +1. And its mass is 1.672 times 10 to the negative 27 kilograms, so extremely small. And then the neutron, which is slightly larger, which has a neutral charge, or a charge net of 0, is 1.674 times 10 to the negative 27 kilograms. And now into more of the structure of what makes up a proton and a neutron. Here we have a proton and a neutron. So protons and neutrons are known as barygons, and they are made up of something that's called a quark, or 3 quarks, which are subatomic particles. And the proton is made up of 2 up quarks and 1 down quark, which make up the structure of the proton. And then the neutron is made up of 2 down quarks and 1 up quark. And they are held together by particles or masses or something that is massless, that is called a gluon. And it's massless in the sense that it is similar to a photon. And that is how the structure of a proton and a neutron are. And then obviously those are kind of clumped together to form a nuclei, and each nuclei is unique in the sense that as you increase the number of protons, you actually create a new element. And so each element has a specific number dedicated to the number of protons, and then those can vary. The element's weights can vary between specific neutrons. So it's possible for an element to have 6 protons, but then have 7 neutrons or 8 neutrons and remain the same carbon element. So here we have drawn up a carbon, and that's what we're actually going to base our model off of. And so in this next portion of the video, I will show kind of a rough take-home self-model that I created myself. So now it is the portion of the video for the demonstration. And when I was coming up up with a demonstration for the structure of a nucleus, I decided to make my nucleus out of snow cones. So here we have a carbon atom with 6 protons and several other neutrons. The protons are in blue here, and the neutrons are in red. And so this is more or less how the structure of the nucleus is composed. Obviously, these snow cones would be a lot more compacted and more of a spherical kind of round shape rather than bulging out like this. But this is the portion of the project that is a demonstration, which is out of snow cones, which I made. So in closing and in summary, we'll just talk or remind you a little bit about the structure of the nucleus. So just to remember, the nucleus is made up of a proton and a neutron, and they are held together by nuclear force, a nuclear binding force, and they pretty much make up elements, and elements have their own specific atomic numbers, which are based off of the number of protons that are found in them. And so in closing, we will hear from a pro wrestler, cook, monk, and scientist on how the nucleus can relate to man.
Where's your rope, Ignacio?
It was stinky, but these are my recreation clothes.
They look expensive.
Thank you. I mean, yes, they may have the appearance of riches, but beneath the clothes, we find a man. And beneath the man, we find his nucleus.
Nucleus?
In the words of Jimmy Neutron, brain blast.